now that we know what the t-distribution is and how it works, we need to be able to find the critical t-values. We need to be able to find these for the same reason we had to find critical z-values back in section 9.1, because it was part of the confidence interval formula right here in 9.1. You can see the critical z-value right there, z alpha over 2, is part of the margin of error, right, which is the z-score times the standard error, and then you add and subtract that away from your point estimate to create your interval. Well, the same is true in section 9.2, except it's critical t-values because, of course, we don't know sigma. So we have our critical t-value, we multiply it by the standard error, that creates the margin of error that we add and subtract away from our point estimate x bar to create our confidence interval. So we're going to have to be able to find those critical t-values. So this particular picture at the top, this is more concerned with chapters 10 and 11, when you have a single tail possibility and everything's in the right tail or the left tail. We're particularly interested in this one right here, which is for chapter 9, which is for confidence intervals. So you have your confidence level in the middle, then you have your alpha over 2 in the right tail and your alpha over 2 in the left tail, just like we did for z-scores. And then we can find those. Well, first of all, because zero's in the center, there's symmetry. So once you find one, you found the other because they have the same numerical value. Just one's positive, the one on the right, and one's negative, the one on the left. And we can find them either with inverse t function on a calculator, that'll be an 84, or an Inspire possibly, or the t-table. Keep in mind that 83s cannot use the inverse t function, they would have to use a t-table. And there are a lot of degrees of freedom that aren't available in that table, so if that's the case, you use whatever degrees of freedom is closest to what you need. Alright, so let's go down here and we're going to practice finding the critical t-values for a whole bunch of different ones. Oops, there we go. Okay, so we want to find the critical t-values that correspond to 95% confidence when n is equal to 17. All right, so you can see I've already labeled the picture. I've got a t alpha over 2 on the right, a negative t alpha over 2 on the left. And yes, you need to label those. Labeling and shading is very important. That's where you're going to get a lot of your points on a problem like this. It's not just about finding the values, it's also about knowing how to shade this graph appropriately. You should have 2.5% shaded in the tail, and it should look like what 2.5% looks like, which, in case you're wondering, looks about like what's drawn here. That's what it looks like. And then 2.5% on the left as well. And both of those are labeled with alpha over 2. They're not just put in as 0.025. You mention what they are, which is the alpha divided by 2. So everything here has to be drawn. There's nothing in this picture that you can avoid when you're drawing it by hand. You have to shade, you have to label, put your center as 0, put your confidence levels 0.95 in the center, all that good stuff. Okay, so let's start with alpha over 2 and how I came up with that 0.025 business. So what I did was I know that the alpha is the complement of my confidence level. My confidence level is 0.95. So I know that the area in both tails put together is 0.05. And then I know I need to cut that in half because the formula says to do so. I mean, if you look at the formula on the formula sheet, it says alpha over 2 right in there in the formula. So I'm telling you with that formula what to do, which is to take your alpha and cut it in half, and that'll be how much is in each tail. And that also tells you what column of the t-table you're going to if you go to the columns, or excuse me, if you use the t-table. We also know that our degrees of freedom is n minus 1, and we were given that n is 17. So we know it's 17 take away 1, which is 16. And that would be the row of our t-table. So now we know the row and we know the column. We could go to the t-table and find the value. And this t-table is right in the appendix, which is where you find your formulas, but it's also where you find your t-values under the t-distribution right here. So we want to go to the 0.025 column, and we want to go to degrees of freedom is 16. Let me double check that. Yes, the 0.025 column and the 16 row. Okay, so let me go back to the table. You can see the rows are labeled with degrees of freedom, DF. So I want to go to the 16 row, and I want to go to the 0.025 column. That gets me a value of 2.120. Now if I go to the calculator, I can get the same value. Let me change my view here so you can see it. There you go, nice and large. So I'm going to go to the second distribution menu, same place you go to get inverse t, but I'm going to get, or excuse me, inverse norm, but I'm going to get inverse t. So inverse t, 0.025, degrees of freedom is 16. I'm going to paste that and then press enter. It takes it a second, but there it is. Now it's giving me the negative value because I put in 0.025, which is a small amount, so it's doing the left tail, just like inverse norm would. So it's negative 2.120, but I know that that's positive 2.120 or negative, depending on which one I want, so left or right. So I have the work right there, which is inverse t 0.025 comma 16, but my answer is actually plus or minus t.025 comma 16, which is plus or minus 2.120. And if you want, you could label those as alpha over 2. That's fine. But the more formal way to write it is to say what alpha over 2 was, which in our case is 0.025, and then comma your degrees of freedom, because of course there are a whole bunch of t.025s. There's one for every degrees of freedom. Or degree of freedom, I should say. All right, so now let's do it again. We're going to find the critical t-values for alpha equals 0.005 with n equals 35. But they're asking us a second question this time. They want to know what confidence level would use this critical value. Okay, so I know that alpha is 0.005, so I'm going to use that to find my confidence level because they're complements of each other. So my confidence level's got to be 99.5% because that's the complement of 0.005. And then I'm also going to take alpha and divide it in half, and that'll be, first of all, the column that I have to go in my t-table, but that'll also be alpha over 2. All right, so my confidence level, I've already found the answer to that question, and it was 99.5%. Highlighted in green for you. All right, now I know that it's the area in each tail is 0.0025 because that's what alpha over 2 is, and that's what I'm looking for when I'm dealing with confidence intervals. I know my degrees of freedom is 34 because n is 35, and that's going to be the row of the t-table that I would go to. So I can either go to my calculator and I can type inverse t, so second distribution, inverse t 0.0025, 34. Make sure you have that extra 0 in there. You don't want to get it confused with 0.025, which is the one we did above. So this time it's 0.0025. And then I get negative 3.002. All right, so let's see if the table backs me up. So I want the 34 row, but I want the 0.0025 column. So be careful. There's a 0.25 column, a 0.025 column, and a 0.0025 column. This is the one we want this time, 0.0025. So I want to go down to 34 for the row, and I see right there it's 3.002. So the table always gives the positive numbers, and then we have to know, oh, I really want both. I want the negative for the left and the positive for the right. Okay, now what about the critical t-value that would cut off the top 5% of scores with the degrees of freedom equal to 20? And what would the confidence level be for that? Okay, so the top 5% means that I'm already giving you alpha over 2. Alpha over 2 has got to be 0.05. But then there's another alpha over 2 on the other side, which also has to be 0.025, because that's the way confidence intervals work. There's always a center and two tails that are identical. Also notice real quick that the degrees of freedom was given to you. It's 20. So the degrees of freedom is 20. That means that n was 21 in case you're interested. Not that we were asked for that because we weren't. But the degrees of freedom is 20. Was pre-given. Okay, so now what's alpha? Well, alpha has to be double alpha over 2. So I have to take my alpha over 2 and I have to multiply it by 2. And that'll get me 0.10. So that's alpha, and that's the area in both tails. And that means my confidence level has to be 1 minus that because alpha and the confidence level are complements of each other, which means the center of my picture is 90%. That's my confidence level. All right, I'll do the calculator first. So I would go to inverse t, and I would say 0.05, or excuse me, 0.05, just to be clear. And then I would say 20, because it already gave me my degrees of freedom this time, so I didn't have to subtract 1. And then I press enter, and I get negative 1.725. Now if I look at the table, I wanted the 0.05 column, but I want the 20 row, which is right here, 1.725. So either way, you're good. And you know that your critical values are 1.725. Now technically this only wanted the positive one. It's the critical t value singular. So it's only the positive side, which is 1.725. If they wanted both of them, then it'd be plus or minus 1.725. One other thing to notice here when you're looking at this table is that there's about 50 degrees of freedom given to you, maybe 45. So here's 40. So it's giving you all the ones from 2 up to 40. But then it starts skipping 50, 60, 70, 90, and so on. So if you don't know, or excuse me, if your degrees of freedom is 52, for example, your best bet is just to go with 50 because that's the closest. 55, you could maybe take the average of 50 and 60. 57, I would go with 60. So you kind of have to estimate if you have a TI-83. TI-84s and Inspires, of course, you have the inverse T function, so you can just use inverse T. At least I think Inspires have it, to be honest with you, I don't know. But I know TI-84s do. So TI-84s always have the options of weird degrees of freedom, such as 52. Right? I could just do that in a calculator. But in a table, if I have a TI-83, I have a table. I don't have this option of inverse T, so I'd have to just do my best and pick a table value that's close. Okay, so we have found critical t values. We're all set there.